Acha. Bismillahirrahmanirrahim. As we discussed earlier, today we are going to learn a couple of terms about waves. Okay. The first term that we have today is complete vibration. Complete vibration. The part of the wave that is repeated again and again is called a complete vibration. If I explain it through a figure, if you remember, we had a figure. We have transverse wave like this, right? So if you notice from here, starting from here, after it comes here, one vibration is completed. How can I say that this is one vibration? Because you will see that the same part has been repeated again. So this is another vibration. See the same thing. Okay, again it is repeated. So this is another completed vibration. Okay, so from here to here, okay, this part is one complete vibration. This is another complete vibration. This is another complete vibration. So in this figure, how many completed vibrations are there?
Three.
Three, right? So we can count how many vibrations are there. So the part is being repeated again and again. Okay, some might say, sir, this part is being repeated. এই পার্টটা রিপিট হচ্ছে কিন্তু এটার সাথে আরো একটা নিচের পার্টও তো আছে তাই না? These two together forms one complete vibration. Okay, this is half of the vibration only. Do you understand this one? Okay, so the part that is being repeated again and again, মনে হচ্ছে না যে এখান থেকে কপি করে এখানে বসে দিয়েছি আবার এখান থেকে কপি করে ওখানে বসেছি? So this part is same, right? So this is one complete vibration. Now this definition is, the second statement is for simple harmonic motion. Simple harmonic motion means, see, whenever we have, let us say this is a tuning fork, I hit it, what will happen? It will start vibrating, right? So this is also having a simple harmonic motion, if you remember. Okay, vibrating particle is a simple harmonic motion. For this one, if I want to define the complete vibration, what will happen? See, let us say it was at the equilibrium position, I pull it here. Okay, from this point it will start moving. So if I leave it, what will happen? It will go to the other end, then it will come back to the same point, right? Then I will say one vibration has been completed. Then again from this point it will go there and come back, another completed vibration. Again it will go and come back, another completed vibration. Okay, so can I say it in this way? If a wave transmitting particle moves from a certain point and again comes back to the same point, then the motion is called completed vibration. Okay, can I say this? Okay, it will start moving from the here and then it will go there and come back to the same point. It will start from this certain point, it will go and come back to the same point. Then I can say one vibration has been completed. Okay, একবার গিয়ে আবার আগের জায়গায় আসলেই আমরা বলবো একটা ভাইব্রেশন কমপ্লিট হয়েছে। ওকে, সো দিস ইজ অ্যানাদার স্টেটমেন্ট, ইউ ক্যান রাইট ইদার অফ देम। ওকে, বাট মোস্টলি আমরা এই কনসেপ্টটা ইউজ করব এখানে। আমরা যে ট্রান্সভার্স ওয়েভটা করি ওটার জন্য এটা দিয়ে বুঝতে ইজি, দ্যাটস হোয়াই আই হ্যাভ রিটেন দিস।
স্যার
বলো
স্যার, if a wave transmitting particle, এটা পরে কি লিখছেন এই সার্কেলের মাঝখানে?
এই যে সার্কেলটা লিখি নাই, কারণ এখানে আমি দেখতে পাচ্ছি যে ওই যে লাইটের রিফ্লেকশন হচ্ছে, এই কারণে আমি জায়গা
হ্যাঁ
লাগাই দিছি যাতে এখানে আমি কিছু না লিখি। ওকে, বিকজ ইউ ক্যান নট সি ইট। ওকে
স্যার, আমরা আর একটাও লিখবো।
আর একটা চাইলে লিখতে পারো, অ্যাকচুয়ালি বেটার হয় আজকে আমরা যদি এগুলো সবগুলো তোমরা তুলতে থাকো তাইলে অনেক টাইম চলে যাবে। সো বেটার টেক আ স্ক্রিনশট অর লেটার ইউ মে রাইট ইট ওয়াচিং দ্য ভিডিও। আমি একটু এক্সপ্লেইন করে করে তাড়াতাড়ি যাইতে চাই আর কি। ওকে, সো আই উইল মুভ টু দ্য নেক্সট টপিক। ও আচ্ছা, ওকে, আমি ইয়াটা আবার ড্র করে দেব। I guess this part. So the next we have is time period, the next term. Okay, so now we have the time required to complete one vibration. See, we said that the wave is starting from here, and when it comes here, it has completed one vibration, right? So the some time will be taken to complete this vibration, right? So the time taken to complete this one vibration is called time period of the wave, because then in the second wave also it will take the same amount of time. To complete the third wave, it will take the same amount of time. Okay, so this is the fixed time, that is called time period. Okay. I'm guessing. So the time taken to complete this one vibration is called time period. Okay, and it is expressed by capital T. Okay, and the unit is second. Let me give you an example. If I tell you to complete this one vibration, a wave takes 2 seconds, okay? Then this 2 seconds is the time period of that wave, okay? So to complete the second vibration also, it will take another 2 seconds, and to complete the third vibration, it will take another 2 seconds. So this is the time period, which is a fixed amount, right? So the time required to complete one vibration is called time period. If you have understood the complete vibration, then the time taken just to complete it is called time period. I hope it is clear, so I can move forward, right? Then what we have, yes, then we have frequency. No. Yes. Okay. Habibi কি আছে? নানা বাইরে গেছে, বাইরে নানা বাইরে যাচ্ছে। আসো আসো তাড়াতাড়ি আসো। নানা কি করে একটু দেখো, যা তাড়াতাড়ি। পাপা মামি তোকে মার্কেট দিব।
Sir, what is that unit S minus 1?
S inverse 1. Inverse.
Okay.
নানা গাড়িতে করে যাচ্ছে। কত সাইয়েন্টি নিয়ে এসে তাড়াতাড়ি আমি দেখবো। এখানে না লিখি। ওকে। নানাকে দেখবো না। Acha. So the frequency is the number of vibration completed in 1 second. We said that this is one vibration, right? Okay. So this is one vibration. There will be some time taken for this. Then this is another vibration. Let us say in 1 second. Okay, I got to know that in 1 second it completes two vibration. One vibration, two vibration. In 1 second it completes two vibration. So I will say the frequency of this one is 2 per second. 2 per second means, see here I wrote 50 per second. If it completes 50 vibration in 1 second, then 50 per second. Per second means 1 second, right? In every second it will complete 50 vibration. But for the example that I gave here, in 1 second it will complete two vibration. Okay, in 1 second two vibration, in the next 1 second another two vibration, in the next 1 second another two vibration. Do you understand this one? Okay, this is the frequency, the number of vibration completed in 1 second. In case of tuning fork, if I explain this one, okay, I will hold this in my hand, and if I make it vibrate, if I hit it, it will vibrate, right? Now later, from if it starts from here, it will go here and come back, one vibration completed, right? Now like that, let us say 50 vibration has been completed in just 1 second. 50 vibration has been completed in 1 second. Robin, তুমি বের হয়ে গেলা কিভাবে? Okay, so if in 1 second it completes 50 vibration like that, I already showed you what one vibration is like, right? So imagine 50 of that completed in just 1 second. Then I can say that the frequency of this body is 50 per second or 50 hertz. Okay, second inverse or hertz, H-E-R-T-S, hertz. And in short, we will write it capital H and small z, hertz. Understood this one? Now why this is per second? That means only second inverse. That one I will show you. Okay, I will explain it with another example. Let us say a wave completes, in 5 seconds it completes 100 vibrations. Now to know the frequency, we have to know in 1 second how many bit will complete. So in 1 second it will complete, definitely it will be divided. 5 second e jotogulo korbe 1 second e tote kom korbe, that is why I will divide. So vibration, so ekhane eta second, so 100 divided by 5, it gives us 20, right? And second ta ekhane niche na, to ei karone eta ki hoye jabe per second. Okay, or I can say 20 vibration per second. তার মানে 1 সেকেন্ডে যদি 20টা ভাইব্রেশন করে, 2 সেকেন্ডে 40টা, 3 সেকেন্ডে 60, and in 4 seconds it will complete 80 vibration, and in 5 seconds it will complete 100 vibration, right? So this is what frequency is. In 1 second how many vibration has been completed. So this is what frequency is. So then we will talk about amplitude. Okay, amplitude is very easy to understand from the figure itself. Okay. Okay, Acha, I will write the definition first. Amplitude. So the maximum displacement of a wave transmitting particle, if I show it in the figure, you will see that this is the equilibrium position. The line in the middle shows the equilibrium position, and from the equilibrium position, sometimes the particle is going in the upward direction, sometimes it is going in the downward direction. So the maximum displacement covered, okay, this is the maximum displacement covered in the upward direction, or we can say the maximum displacement covered in downward direction. Both of them will be equal. From the equilibrium position, the distance that will cover in the upward direction, the same distance it will cover in the downward direction also, right? Because sometimes it is going up, sometimes it is coming down, right? It is going up and down like this. So the maximum distance covered, okay, from here, from the equilibrium position, it is called the amplitude of that wave. Okay, it will be same for all the crest and all the trough. If you remember crest and trough, yesterday we discussed about this. Okay, this is the crest, the maximum position in the upward direction, and the maximum position in the downward direction, that is called trough. Okay, so the distance of crest and trough, we can say this also. Okay, the distance of crest from the equilibrium position is amplitude, or the distance of the trough from the equilibrium position, that is also called amplitude. Okay, so this is the maximum displacement of a wave transmitting particle from the equilibrium position is called amplitude. Now already I have written the amplitude is expressed by A. I want to know what is the unit. Okay, and I have underlined for you to get an idea. What will be the unit? Can anybody tell me? Sania and Salman, they are joining late. Nobody can tell me what will be the unit? It is a displacement or a distance, right? So what is the unit of distance or displacement?
Meter.
Why did it took so long? The displacement. Okay, we calculate displacement in meter, right? You should have answered long back. Meter. Okay, so amplitude is a distance or displacement, and so the it will be okay. Okay, so this is amplitude. Achha, then we have phase.
Yes, teacher.
Mute yourself. Okay. Now let us discuss about the phase, the overall condition of motion of a wave transmitting particle. Phase, এটার বাংলাটা আসলে বলে তোমাদের বুঝতে ইজি হবে অবস্থা। phase এর বাংলা হচ্ছে কি অবস্থা। আমরা বলি না যে দোস্ত কি অবস্থা, বিষয়টা অনেকটা ওইরকম। ওকে, মনে করো তোমরা কয়েকদিন পরে গ্রাজুয়েশন করে চলে যাবে স্কুল থেকে, তাই না? কয়েকদিন বলতে কয়েক বছর, বাট ইট উইল সিম লাইক কয়েকদিন অনলি when you graduate. সো তারপর অনেক বছর পরে যখন আমার কারোর সাথে তোমাদের কারোর সাথে আমার দেখা হবে কোথাও লেটাসে, তখন আমি জিজ্ঞেস করলাম যে মনে করো রবিনের সাথে দেখা হলো, রবিনকে আমি জিজ্ঞেস করলাম এই তামিমের কি অবস্থা, তুমি জানো নাকি? তখন তামিমের অবস্থাটা এক্সপ্লেইন করার জন্য তুমি অ্যাকচুয়ালি আমাকে শুধুমাত্র একটা ইনফরমেশন দিবা না, তুমি আমাকে একটা ফুল সেট অফ ইনফরমেশন দিবা যে হ্যাঁ স্যার ও ফিজিক্যালি ভালো আছে, আবার ও মানে ফিনান্সিয়াল কন্ডিশন ইজ গুড, he got married and he is having 2 kids, one boy, one daughter. Okay, one boy and one girl. So a set of information you will give me to explain the avastha of Tamim. Do you understand that? That is the phase of Tamim. Okay, now I want to know the phase of a wave transmitting particle. So there should be a set of information, right, that you should be giving me. If I ask you what is the phase of this particle, then the overall condition of motion of a wave transmitting particle at any moment is known as phase. Overall condition. Now overall condition is a set of information. What are the information that will be included here? For example, they have written the displacement of the particle. We know that. Okay, let us say any particle is here at the point at this moment, right? So what is the displacement from the equilibrium position? What is the displacement? Okay, so that is the displacement. And what is the acceleration? There will be constantly change of velocity. Okay, so there might be acceleration, or if there is no change of velocity, then the acceleration will be zero. This is also information. And the velocity, at what velocity it is coming up and down. Okay, so all this set of information together is known as the phase of the particle. Okay, now if you notice, if I ask you that this is a point ক্রেস্টে যে পয়েন্টটা আছে সেটা একটা পয়েন্ট, ওকে, ওটার একটা ফেজ আছে। এখন এরকম সেম ফেজের আরেকটা পয়েন্ট যদি আমি তোমাকে বের করতে বলি, তুমি কিন্তু আমাকে কি করবা জানো, নেক্সট ক্রেস্টে যে পয়েন্টটা আছে না সেই পয়েন্টটাও কিন্তু সেম ফেজে থাকবে। বিকজ এই যে দুইটা পয়েন্ট এরা কি করবে, একই সাথে ওঠানামা করবে। এই পয়েন্টটা যখন নিচে নামবে ওই পয়েন্টটাও তখন নিচে নামবে। আবার এরপরে যে আরেকটা ক্রেস্টের যে পয়েন্টটা আছে না সেই পয়েন্টটাও কিন্তু একসাথে ওঠানামা করবে, ওকে। So please be very clear about this one. Again, if I tell you about trough, এই যে এই পয়েন্ট আর এই পয়েন্ট, এই দুটোটা পয়েন্ট একই সাথে এখন নিচে আছে না, উঠার সময় ওরা একই সাথে উপরে উঠবে। That means they will have the same displacement, same velocity, same acceleration at all the time during the wave. Okay, so এইসব পার্টিকেল গুলোকে আমরা কি বলি, the particle of the same phase. Okay, these are the particle of the same phase. Again, we have less than 10-minute time. Okay, so this is called the phase of a particle. Anybody has any doubt? No. Okay, so then the next one we have wavelength. Wavelength. What will be the unit? Wavelength, what should be the unit? Can you tell me? Again, I will give you a hint, or else in the name itself it is written. What will be the unit?
meter,
Meter. It is a distance, right? Acha. Now let us try to go through the definition. The distance between two successive particles of same phase. মানে দুইটা পয়েন্ট আমরা নিব, এটা অনেক দাগাদাগি হয়ে গেছে, আমি নতুন একটা ওয়েভ এখানে আঁকি, and I will try to draw it in a bigger way. Okay, এখন দেখো তো এইখানে যে পয়েন্টটা আছে না, ওকে, সেম পয়েন্ট I will get here. No, the same point I will get here. Okay, after one vibration, okay, the same point is repeated. দেখো এখান থেকে একটা একটা ওয়েভ শুরু হচ্ছে, এখান থেকে কিন্তু একটা ওয়েভ শুরু হচ্ছে। So after one vibration I get the same point, right? So the distance between the points of same phase, see this particle and this particle, both of them are having the same phase, right? Both of them will go up together and both of them will come down together. Okay, so the distance between them is called wavelength, and wavelength is expressed by this lambda. Okay, lambda কিভাবে লিখবো, এটা এভাবে একটা দাগ দিয়ে এভাবে একটা টান দেব। So this is lambda, and as this is a distance, this is called, the unit is meter. Okay. Now, or I can say the distance covered to complete one vibration. See, here I am actually completing one vibration, right? So to complete one vibration, the distance that I'm covering, okay, the distance covered to complete one vibration is called lambda. So I can put it in this way also. Okay. So remember, now somebody can ask me, we have a point as crest here, right? Okay. Then another crest will be here. The distance between them, can I tell this is a wavelength? If somebody asks me, what should be my answer? Okay, can anybody tell me whether I can name that one as wavelength or not? Yes or no? Just express your opinion. You don't have to be right. Okay, you are students.
Yes.
Yes.
Yes, I think this is a wavelength. Very good. Okay, because I have taken two successive particles of the same phase. Okay, now if you notice, Papa, ক্লাস নিচ্ছে ওটা আওয়াজ করিও না। দেখো এখানে একটা ক্রেস্ট আছে, আবার এই ক্রেস্টটাকে বাদ দিয়ে আমি যদি এই ক্রেস্টে চলে যাই, তাহলে কিন্তু এদের মাঝখানে যে ডিসটেন্সটা, এটাকে কিন্তু ওয়েভলেংথ বলা যাবে না। ওয়েভলেংথ হওয়ার জন্য টু সাকসেসিভ পার্টিকেল হইতে হবে। সাকসেসিভ মানে পর পর। তো এই যে ক্রেস্ট আমরা নিলাম, ঠিক এটার পরের ক্রেস্ট পর্যন্তই কিন্তু আমি যেতে পারবো, নট বিয়ন্ড দ্যাট। ওকে, সো দ্য ডিসটেন্স বিটুইন টু সাকসেসিভ ক্রেস্ট ক্যান বি কল্ড এজ ওয়েভলেংথ। আবার the distance between two successive trough can also be called wavelength. Okay, so you can write the definition in many ways. Please আওয়াজ করিও না, নাইলে ওরা আমার কথা শুনবে না। Okay, please. Okay, so now clear the wavelength. Okay, you can write the distance covered to complete one vibration. Okay, এখান থেকে এখানে কিন্তু একটা ভাইব্রেশন কমপ্লিট করে, or we can say Papa, please don't cry. Okay, Papa কোলে আসো আসো, don't cry. দেখো পাপা কি বলি একটু দেখো। So the distance covered to complete one vibration, see if I start from crest, then what will happen? Here I will complete another vibration, right? So the distance covered to complete one vibration is lambda. Okay, or you can put it in this way, the distance between two successive particles of same phase, they both are in the same phase, right? That's why this is called wavelength. Anybody has any doubt regarding wavelength? I don't think so. Thank you. The last term that we will learn today is wave velocity. Let me check how many minutes are left.
Sir, only 2 minutes.
2 minutes. Okay, wave
Tomorrow.
velocity, take 1 minute only, no problem.
Sir, tomorrow.
Yeah, tomorrow we will have another 40 minutes. That one I know.
Oh shit.
See, wave velocity. Velocity you already know, right? That is why it will take very less amount of time to study wave velocity. Okay. Okay, this is wave velocity, the distance covered by the wave in unit time. Unit time means it may be 1 second, it might be 1 minute, it might be 1 hour. Okay, depending on whatever you choose. Whenever we are showing the velocity of an object, we generally use meter per second, right? Okay, but while traveling in cars, we calculate the speed or velocity in kilometer per hour, right? In 1 hour, how much kilometer we are traveling, right? So it depends on you. Unit time, the time unit, you might take kilometer, hour, second, minute, whatever you want, but generally here we will take second only. Okay, so the distance covered by the wave in unit time is called wave velocity. Let us say, oh okay, symbol, the symbol we express it with is v, velocity. Okay, so v, and unit, what will be the unit? What is the unit of velocity? For general purpose we will take meter per second. Okay, then if I give the explanation, okay, let us say in 5 seconds a wave travels 200 meter. But to find out the wave velocity, I must know in unit time how much it travels. Unit time means in 1 second. Unit means 1, right? So in 1 second, the wave will travel, okay? Definitely it will travel less, right? In 5 seconds, it is traveling 200. In 1 second, it will travel less. So I will divide it. So 200 is meter and 5 is second. So it will be 40 meter